TechRabbit here. So now we're going to dig into Proxmox VE, and I mean, the first question is that why should you care about Proxmox virtual environment in the first case? And in my case, if you've been following my videos, I've invested in some HomeKit servers, and I'm going to be using one of them as an example to demonstrate this VE usage, and that's a server that has 4 CPUs with a total core count of 144, and it has 128 gigs of RAM and 8 terabytes of disk space and a 10 gigabit networking interface. So what I'd like to do, or what one would probably like to do with that hardware, is to actually maximize the utility of the hardware. And also I would like to not only run one operating system on the hardware, one would actually like to have the option to run multiple different operating systems. So run more than one operating system. And also it would be cool if one could run small function specific services, entities that do very specific things. And I would also like it to be easy to do the initial setup and management of the environment, so one doesn't have to spend many hours figuring out different things. And then of course there's the option that if one actually goes ahead and upgrades the server, that will be easy to share that hardware with the components running on the server. So if one throws in a graphics card or two, or more memory or disks, or various kinds of resources, that would be easy to share them. And in the case of Proxmox VE, it actually embedded in it supports KVM based virtual machines and LXC containers, and you can run KVM and LXC stuff just on you take a vanilla Ubuntu, and then you can just install the extensions, and then you can run those virtualizations. But then you lack the infrastructure around it for maintaining and managing it, so that you have to do manually, which doesn't make it that easy to control the environment, in my opinion. So in the case of Proxmox VE, you have what I consider a relatively well-made web-based management interface that enables you to, on a high level, control these different things. And it also, when you get into the VE, then you can actually control things way beyond just running a KVM virtual machine or an LXC container, so that then you can actually, as I said, you can add additional hardware and share it, but then you also have the infrastructure for taking backups. You can actually it has clustering support, so you can have more than one server, one Proxmox VE server working together. You can do things like live migrations from one server to another, and storage add-ons, all endless amount of different stuff that you actually don't get if you're just running vanilla KVMs or LXC. I mean, I think that it's of course, if you have very specific use cases and a very limited number of virtual machines and containers you're going to run them, you could probably get away with it by just doing a standard OS install and then having those extensions, and then set up the. But if you have to manage lots of them, and you need to distribute it over several servers and have fallback solutions and stuff, both for the storage and the virtualization, then it's actually quite nice to have the Proxmox VE environment. So let's take a little bit closer look. My installation is the Proxmox VE 9.0.3 version, and when I was making this video, the latest version that's available from the download site is 9.1, and I'll include the link to where you can download the ISO image. What I did is that if you looked at my previous video, then I basically explained how to install Ubuntu Server Pro and the basic installation preparation. You know, the common post install activities are identical to Proxmox installation, so I won't be repeating those here. And then also I want to say that Proxmox is a open source solution, and it's freely available. But they do have the Proxmox VE is also a licensed product. So that if you buy a support license for it, then you get. The way they've locked it is that if you want to go from one VE version to the next, then you have to pay this license, this support fee, so that you have easier upgradability between versions. So in my case, if you wanted to make a clean upgrade to the next version of Proxmox, then basically if you want to do it perfectly, you have to like wipe the server and then install that version that you want to use. So that's the only way that you get blocked, as far as I've seen. There's no functional blocks that I have been able to identify if you don't have the license. But it kind of messes with you if you want to like upgrade from one Proxmox version to another. Then that's blocked. But otherwise, the security updates and stuff you will, the normal course OS security updates and stuff you will get. So you're not blocked from getting that. Then when you do the installation, then you the way I did it is that I did it similar to the way I installed the Ubuntu Pro, that I used had an Ethernet cable connected. And then in this case, you need to prepare yourself with a fixed IP address. So the installation will actually ask you what IP address you want to use for the server, and then which can catch you out of, if you're not aware of it, that the login user, when you have actually completed the installation and you get the login prompt, the username, the default username is root. So that was what you were giving the password for. Just a small observation. So anyway, let's so basically in this video I'm going to be covering more like how do you use the basic features of Proxmox VE, and I'm going to go through a few examples on setting up a container and typical container configuration and a typical virtual machine. Well, a non-typical virtual machine, just to be able to demonstrate the VM capabilities. And yeah, so let's get started. So now that you've got it installed, then you can go to this. This is the IP address you go to. Yeah, of course it'll be your own IP address, but that's the format. So it's port 8006, and then you get into the administration interface, and there is one thing you need to fix before you remove the Ethernet cable. You need to fix the configuration for the fiber port, otherwise it won't start up. So the way you do that is that you go to the server view, and then you select on the server, and then you select shell, and you see, you get it automatically get to the shell for the server. And then what you need to do is you need to edit the interface definitions for the network. So that's that one. And then what we want to do is, as you see, this is the, like from the previous video, these are the Ethernet. So that's 49, 50, 51, 52. And then we need to add the because in my case they were missing from this file, so then I put the definition for the main definition for the network card, which is the NS9 in my case, and then I put the definition for the specific fiber input port configured here. So those basically these lines here I need to add, and then I need to add the specific fiber port to the bridge port settings, and then it automatically executes all the files in the interfaces. So the way I noticed that it was best to boot after you've done those changes, you could actually just execute the command to execute all the files that are all the config files in the. I'll show you. You could basically just execute that and then hope it works. But in my case, it didn't seem to initialize it properly. So what I did is I actually rebooted, and then I tried this also, like restart the networking subsystem. Didn't seem to really bite it either, so I decided I'd reboot. I decided to reboot the server, and then you get and then I took the Ethernet cable out, and yeah, if you had the patch cable already installed, then you don't have to install. But then I put the patch cable in, so I removed the Ethernet cable, put the patch cable in, and then rebooted the computer, and then I got let's see here VMBR0. There, it's the D1 is the actual fiber interface, and then we have the bridge configuration came up online with the IP, and I was able to ping it, and everything was working fine. So I'd just like to give a positive mention for the documentation. That actually is pretty good. I mean, in a world where we're getting more and more used to that, nothing has any documentation now. We're just supposed to Google everything. But in this case, they've actually included quite good documentation. I mean, in some instances, it's not 100% up to date, but I'll give them a thumbs up for actually including at least something. So the majority of the use cases and functionalities are documented and commented there. So it's not a waste of time visiting the documentation if you have any questions. So anyway, and then so okay, now I got this nice environment. So the issue is that, okay, how do you set up stuff here? So then usually when you want to set up stuff, you need to have templates, you need to have access to ISO files, and the first thing I'd like to show is that, okay, where are the ISO files? So if you go to your server, so to locate the ISO images, you go to the server, and then you expand it, and then you go down to the bottom, and you take local, and then you have ISO images. So these ones here, this is everything that I've uploaded. So what you can do is you can go on the internet, or for other sources you have, and you can download your ISO files to your own machine. And then to get them onto the Proxmox server, then you use the upload functionality. So you go to the upload window, and then you just select the file, and then it will run a task to upload it in here. So this is how you make ISO images available on the Proxmox server for further use. And if you want to have containers, then it's based on a concept of templates. So not ISO files, not full installations, because it's basically a pre-configured, boxed functionality. So in this case, here are the ones that I've actually selected to use. So there's different container templates, and then you can upload those, or you can actually, and the other way is that you can go to the already predefined template list here, and then you can select what template you want to use, and then you can just download it and add it to that list so that it's you make it available for usage on the Proxmox server itself. So now you've got your ISOs in place, you've got your templates for the container templates in place that you want to use. Then you can actually start the process of creating your containers. So what I've done is I've created a virtual machine and I've created a container already, but I'm going to go through the process of creating both so that I can show the mechanics of actually doing it, and then I'll just jump into the ones that I already created, so I don't have to wait for the installation to complete for the container or the virtual machine. But anyway, so the easiest way to create a container is you switch to folder view, and then as you see, automatically get the entries here for containers and virtual machines. And then you can see, as you see, I've already set up a whole bunch of containers. And what I intend to do is to just make an example of creating a MySQL, an additional MySQL, because the thing is with containers, they're lightweight machines, lightweight box, black box functionality. So you can actually, if you could, for example, create a MySQL, which is a database server container for individual databases. There's no rule that says you need to create one container and then it should run all your databases. Actually, it's more common that you will create application-specific database servers, because these are lightweight. Compared to virtual machines, these are much more lightweight stacks. So that you can actually justify creating multiple database servers for multiple applications. And the benefit with that is that if one of the databases gets screwed up, it won't have any side effects on another database running on the same machine. But let's have a look and see how we create ourselves a new machine. So basically up here you have create VM and create CT. So I'll just take the create CT. And I'm just going to show the basics. I mean, there's lots of different options and lots of different configuration parameters one can use, but I'm only going to use the absolute basic settings that are needed to get things up and running. So you need to actually say, okay, what do you want the machine to be called? So I'm just going to call it CT 2, 3, 5, just 5. And then you need to actually give a password for this container. And I'm just going to use 1, 2, 3, 4, 5. Shouldn't do that, so you should always give a strong password. But for this case, I'm going to delete this after I'm done with it. And then you as I said, that I could spend a whole day about all the details on these configurations, but you can actually preload SSH keys and lots of stuff. But hey, let's not get stuck. Let's just move on. And then here it says, okay, the storage you're going to store it in is local. And since I got a very simple configuration, you don't have to care where it ends up. And then here you can, now it lists the everything that you've set up in the templates list for the container templates. And this is where usually lots of people get caught, is when they don't set up their container templates, and then they come to this list and then there's nothing in the list, and then they panic because where do I get the templates from? Because they don't realize they have to set up the template list before they start here. So anyway, let's just take the MySQL. And as I said, that these are not the only template. You can actually go onto the internet and download other template implementations based on other operating systems, and a very large amount. And then we move on. And also you have this so-called advanced, if you take this away, then it takes away basically lots of settings. But I wanted to show the settings. So if you take advanced away, then it will show only the manager. but I wanted to show the everything, all the options, even if we're not using. And then this is where one gets to the collision between virtual machine configuration and container configuration, because this is configuring a container. Container is it basically it shares a lot of the infrastructure between the different containers. So you, for example, don't need to assign so much disk space and so much memory that you would when you're dealing with a dedicated virtual machine. So it gets you a bit of a shocker when you say, oh, what do you mean only 8 gigabytes of disk space? That's not enough for anything. But if you're looking at, when you are working with containers, then you can actually do this. You can use much less resources, because you're basically only looking at the resources for the actual functionality, not for the supporting operating system and the stack. But anyway, we leave it at 8 for this one. And then we have the number of cores, and this is also the thing, is the same thing with containers, that it can actually, if you do this, for example, database separation, where you create a dedicated MySQL instance for each application, then of course you don't need to have, like, for each instance doesn't need to have 40 cores available. It might be able to actually happily run its specific application request on a very few number of cores. So we can just leave that as is. And then again, memory, same thing. So this is the memory for the actual functionality. It's not really the memory for the whole stack, because the whole stack shares memory use, and so the OS on that layer shares capacity, memory capacity. So this is talking about how much memory you do want to dedicate for the actual functionality of the MySQL feature. So we can leave that by default. Of course, all these can be tuned after the fact, so it's not like a permanent set. And then networking. And here, just for simplicity's sake, my trick is that I assign DHCP, so I get the system up and running. And then if it's a container or a virtual machine that I want to use on a continuous basis and I don't want the IP address to change, then I actually fix the IP address in my router instead. So I don't fix the IP address. I don't configure IP addresses in the containers and virtual machines. I just go to the router and I say that, okay, this MAC address should have this IP address permanent. And then there's in my case, no need to change for DNS configuration. And then it's a confirm, it's just shows all the options that have been selected. And then, as you see now, it's taking the template and make it into this unique instance of the for this container. And these warnings I'm getting about the pools running out of space. The instances that I have configured it to use the full extent of the storage capacity I have on this machine. So, but usually, what a Proxmox configuration, what you will do is that you won't actually take up all the space you have available. You will start with a small amount of space, and then you will use this pooling and auto extending capability, so that it will actually automatically extend the storage as it needs it. But I decided I'll just take the whole thing. So anyway, that's done. So now we see we got this 119. It looked like I was talking, I gave it the same host name. Right. But anyway, it doesn't matter. We can actually just run this anyway, because this is the one I'm going to actually delete, but I should have given it a different name, but I didn't, so but as you see, it gives it its own unique ID for the container. So anyway, when it's done, then you click on the actual container, and I'm just going to show you this because it does exist. So now basically it's as clean as it's ever going to get. So what you can do is that you can actually go into snapshots, and you can take a snapshot, like a picture of the situation as it is now, even before you've even done even before you've done the first startup and the initial configuration. And then also there's a backup option where you can actually back it up now, so you can take a backup of it also. And actually backup is based on snapshot, so usually speaking, when you take a backup, it takes a snapshot and then backs that up. But you can actually run a backup directly, so the more conventional way. So they keep it keeps the separation between snapshots and then actual backups. And then we can go to the console window. So this is the console window for the actual container. And then we have here in the console button, you have a little bit different options. You have no VNC, which is the default display, and then you have Spice, which is more advanced display, and then you have the external JavaScript, which is the JavaScript implementation for X Windows. But anyway, for when you're running containers, it's going to be just text-based stuff, so you can actually just use the no VNC defaults. Oh yeah, I'm going to put the link where you download the client for the Spice. When you select the Spice option, then you need an actual a separate software. So I'll put the link for that in the clients. So you need the Virtual Manager client, and then we just say start. And then it boots up. And this is not the containerized. The whole idea with the containerization is not the full operating system. So basically, it's sitting on top of a layer of operating systems and stuff. Let's see, root, and then the password. Oh, that was really complicated. 1, 2, 3, 4. Who gave it such a simple password? So, and then and the reason I'm showing this container installation is that pretty much each container follows the same kind of a process where you install it, and then when the first time you log into the container, because you would think that a container, why does it even need to have interactive features? But it actually does. That then when you start up the container for the first time that you actually give it the application specific basic configurations. So let's see. And that was the password. Is it the new password? So that, yeah, here you give the MySQL adminer password. This I will make a bit more complicated. It's for my notes. And then then this is the specific password for the remote user. And then their initial hub services. Now there are hub services available where you can actually connect to a centralized service for it to take backups of your server automatically and stuff like that. But so you sign up for that service separately, and then you can have an API key, and then you put the API key in here, and then basically it off-sites your data to a secure location. If you want that kind of automatic stuff, but I mean, since I'm a HomeKit owner, I don't really care. So I'm going to select to skip that. And this is also it does the same capabilities for posting, so you get emails, alerts, and stuff. So I just skip that. And then the last thing it will ask for is that, which is actually good, is that we'll also ask you, do you want to apply security updates right now? You can also apply them later. And it's actually a good test for the network connectivity and stuff, to actually see that it can actually download all this stuff, so then you know you have a working, a stable working network connection. Otherwise this update will fail. And then this will probably want to reboot also. So, you're back when it's done. So, now it's finished installing the update, so I can take a coffee break while it's rebooting. So, coffee finished, reboot complete. So now when you log in, then you just get this. So it's like completed the initial configuration. And this is, as I said, this is pretty common to each kind of template, and of course what it asks for is relevant to what is the container for. Is it a database, is it a node container, or whatever it is. And but the idea with this containerized template structure is that the actual install and setup process should be similar, as similar as possible. And as I said, that if you want to manually install the updates, then you have this special command you can issue. So this command here will install all the security updates, and you can actually periodically run this also if you don't enable automatic update. And then to access the character-based built-in console that we use, and it's actually commented here also, so then you can have that. And this is actually quite good. So there's I mean, the idea behind this structure is that it's a character-based menu-driven system, but you know, it gives you access to, and one of the main things, the interesting thing, is the networking configuration. So here you can actually see, well, has it picked up correct? And then in this case, I could use this. I could come out, since I'm using DL, I could see what IP address it's picked up, and then I could go fix that IP address. But you can also configure static. And then there's encryption, mail support, proxy settings, region config, system settings. MySQL, remote SSL, blah blah blah. So lots of stuff. And then there's the usual reboot, shutdown, and quit to actually get out of here. So then you can go back to the console. So anyway, we're done with this, and it was a mistake that I set this up, because I put it up with the same host name, so now I actually have to get rid of this, so yuck, hate this container, I want to delete it. So the first thing you do is you go to shutdown, and then you can say stop, and then you can say yes. So now that it's shut down, and that's indicative of this kind of blank display, and then the start is in this status here, and then you go over to the left hand side and you right click, and then you find out there is no delete function here, so what? And then actually it's hidden up here instead. I think they did this for security, safety reasons, so you don't just accidentally hit the remove. So it's actually in the, up here in more, remove. And then you need to actually enter the ID if you want to get rid of it. And then purge from job and destroy unreferenced tasks. And then you just say remove. So then it's gone. Covered. So as you see, it's quite easily to both create containers and then remove. And now I'm going to continue. I'm just going to use this my originally created container for the rest of the demonstration. But this is a MySQL container also. So actually, surprisingly enough, there's a little bit more in terms of administration capabilities. So when you go to the IP address of your MySQL container, then you get this menu here, so you actually get a control panel, and then you have two different interfaces you can choose from. So you can have web admin and then adminer, and I won't be going into extreme detail in any of these, but adminer is basically the database handling part, and then web admin is the web administration. So if we go here, so then you come into quite an extensive web administration user interface with this. Lots of different backup handling and change password and all kinds of stuff that are more on a higher level than just the database handling. And one of the most interesting features here is that if you go to tools and then you have terminal, so that you actually get a web-based terminals come in here directly. And for those that have worked with MySQL, you might want to scroll a bit forward, because now I'm going to give a basic example of how to set up a database and user on MySQL, just to demonstrate that part. And because basically you do these same kind of procedures with other containers, even if it's going to be for a different purpose. So I think it's interesting to train into the mind that, aha, this is how I set up a container, and then I start the container for the first time, and I do some basic configuration, I apply updates, I get access to the administration console there, and then aha, there is a web-based, and on top of that is then a web interface for managing more application-specific functionality. Like you saw here, you have this web admin, webmin, which is more for the server top-level handling. And it's loosely connected to the underlying dedicated container features, and then you have the administration interface also for the what that specific container does. So I think it's actually a good training session. So just to drill it into the mind, then we'll go through this basic procedures here, and you can do it in this terminal now. So we basically access the actual database. And here you have to actually use the database password, not the root password. Where did I put it? There. No, it's that one. MySQL password needs to be used here. There we go. So now we're into the Maria database or MySQL management interface. Command line. And when you want to create a database, basically all these commands are SQL language basically. But then you issue this command to create a database. And then when you want to create a user, you use this command. Now then there's a bit of a trick here that this percent thing is that it says you want to create a user Rolf at percentage, which means that actually this is very confusing because the at means as to where is the user coming from. Is it like is the user logging in localhost, or is it logging in from a remote machine, or are you going to use this percentage the character, which means that it accepts the login from various sources. So when I create the Rolf user here with the percentage, then it means that I can log in with that username from wherever. And then now you have a user, but you also need to say, okay, what does that user have access to, and what are the privileges levels? So then I say grant all privileges on just created my database, and then everything in it also. So all tables basically, and then I grant it to this fully qualified user, because I can actually have Rolf, which was a bit weird. I made a mistake. I created a Rolf at logging in from everywhere, and then I could actually have, in parallel with that, I could have a Rolf at localhost or a Rolf at an IPS. I don't know, that felt a bit weird to have, but it's still the system allows it. And then when you do this privilege handling, then you actually need to use this flush privileges. So I suppose that's what happens. You can do different setup procedures, a whole chain of them, and then you can say, okay, flush it in one go. So in some instances, giving partial security accesses and stuff might actually not be such a good idea. So I think that's why they designed it that way. And then you can also look at all the databases created. So these are system databases, basically those, and then this is the database that I created. And then there's various ways you can look at what users are defined in the system. So this is one command, so you can basically you get all the users, and these are system created, and that one is also system created, and then you have this is my user. And then you can do different filtering tricks. I can say, okay, who has access to this specific database, and then it shows that it's only me. And then, or you could actually do the other way around. You could ask, what access does a specific user have? So then it will show you that. And maybe we could give this example also. So I'm just going to put one record in the table just to demonstrate. So to actually activate the database for the commands that I'm going to use, then you say, okay, now you use this database, and then it says database changed, and then I'm going to okay, it actually, I copied one line too many, so it actually copied the enter key. But what this does is it's creating this table in the database. And then I'm going to check that it actually ended up there correctly, so I'm going to ask it to describe it. And as you see here, we have the people table, and then it's giving the fields. And then I'm going to put one name into the database. So insert into the table people into these two fields, these two values. Not that magic. And then I'm going to actually have a look and see, did that data actually end up in the table? And yes, it did. So let me have one. And I think we leave that like that. So anyway, not much point in having a database in a container if you can't use it. So I asked artificial intelligence to create a program in Python to populate the database in question, or the database table, and then spent the usual the usual time it takes to correct the mistakes that the AI had made. But anyway, I think that AI is reasonably useful, but I must say that it does itself generate quite a number of hallucinatory errors of various kinds, both in the syntax and then the functionality. So one has to be very careful how one actually formulates the questions to AI. But anyway, that's a side issue. But anyway, I made I'll probably package this up or if any other code, and then put it on my GitHub site so you can actually get it. But I mean, this is base simple, so basically it has an add people function that just it connects to the database, the container, and this runs on my own workstation, so it's communicating with the Proxmox container and with the login information, and then basically it creates 3 new people in the database, and then here it does the try, so it connects, and if it's connected then it does the insert stuff, and then we get more names in the database. So then I'll just run it here, and then it says 3 names were inserted successfully. And then of course, being paranoid, we don't believe that. So then we actually have to go back and check, and then we can do that in the same interface. Oh, look, it actually did write 3. So now I wanted to include that to actually say, okay, now we've created a container and we've configured it, and we've seen the admin interfaces and stuff. But I mean, can you actually use it? So I just wanted to have a simple demo that's a Python program that's running on my own workstation. I'm communicating with the Proxmox server, and then through the Proxmox server infrastructure to the actual container, so that one sees the one has an actual working container for various purposes. I mean, it doesn't have to be name. Yeah, it can be whatever handling you want to have. And yeah. So that wraps up using lightweight containers, and as I said, there are lots and lots and lots and lots of different containers for various different reasons, created for various different reasons. So I suggest that when you're in this world of modularity and services-based development, then I suggest you just get used to this fact that if you want a database, it'll be a container somewhere. If you want to have a node server, it'll just be a container somewhere. If it's going to be XYZ, a file serving service, it's going to be a container somewhere. So that's just the way. For most of these like non-generic specific services, they're probably just going to end up being containers. This will of course evolve into when you now have agentic AI, then basically you'll have containers which will do specific AI feature functionalities and features with the models already predefined and everything. So I think that this age of really getting into the details of technically how AI works on a low level is totally pointless, because this is evolving very fast. So basically what one should focus on is, okay, how does one start using the service infrastructure to connect different AI models together to do useful things. Yes, so let's move on to virtual machines. Just before we move on to virtual, I did actually make that exact same example in Rust, but I won't go through the details of that. I'll throw it into the package that I'll put on the GitHub site. Anyway, looking at virtual machines, so let's see. So here I'm going to do, basically I already have a machine, but what we will do is, just so that I can actually demonstrate the process of how to create a virtual machine, we'll do the same trick of actually going through the steps of creating and configuring the virtual machine. So then we just say, well, it was containers, and now we're going to create a full virtual machine. Also the same thing, that you can get rid of this advanced feature, so you can only see the mandatory fields. It makes it a bit easier. But as I said, I like to keep it activated, because then we can actually see what's going on. And now I'm going to remember to change the name of the host name so that it doesn't collide. And let's see if somebody guesses already what I'm going to install. There we go, we're going to the next one. And then we select it. Now this is kind of a meme Linux distribution. It has been rumored that this has actually been maintained up to 2026, but I can't find any evidence of that. So, but for this example, I'm using it because this is an odd Linux distro created in Spain by some enthusiast, and it's basically a themed Linux, and it was like 2010 or something, when there was the peak of the some TV series, Hannah Montana TV show. And I'll put a link where you can get this specific image from. Not that it's not super interesting, but I'll include it in the comments anyway. But the reason I'm including this is an example of, like, you suddenly okay, you're in a situation you would like to actually review or install a semi-ancient Linux distribution, and when you try the default VM setup, then you notice that it doesn't work. So I'm going to walk you through all the tuning tricks that I did to get this 2009 Linux version to work on the virtual machine, which it actually does very well. So this shows the power of the virtual machine configuration, that you can actually create, or how rich this virtualization is, that you can actually have a certain physical configuration like I have with the server, but then basically with virtualization you can turn that server into whatever kind of a server you want, or whatever workstation configuration you want. With some limitations, of course. So that the software running on top of the virtualization thinks that it's running on a completely different machine. So that one, and then I have to be careful that we that was that one, and then there was no change here. And we were actually going to be we're not going to be using the SCSI controller, but and there's a little bit of a bug or a feature in Proxmox where it says that if you don't have any attached devices to the SCSI controller, the SCSI controller should not exist. It should vanish, but it actually doesn't. And in these default configuration wizards, then you actually always have this. So you see, there's no option to say that it doesn't exist. You always need to have a SCSI. But I found a way to work around that. So next, and then so here we need to switch to SATA. So that's one of the legacy changes that one needs to do. Actually forgot to write that down in my hints here, so I'm actually going to put that. I missed to update my comments here. Okay, and then yeah, and then we don't make the disk too big because this they didn't have very large disks than that. So that should be okay. And now we can actually make 4 cores. That's quite reasonable for that type of. And then here is where it sort of bombs out. So I found that if I take a real basic CPU emulation in QM64, that one seems to work the best for the specific machine. But as you see that you can actually, independent, you can go everything from, let's see, where was it? It was at the bottom. So you can say host, which means that it will totally wrong word. It will emulate the actual processor you already have on the machine. So it will tell the VM that it will think that it's using the processor you actually have in the machine. Or then you can actually select from very many different types of going all the way back in history. You know, Cascade Lakes or all kinds of stuff. And then even the Epic IMD stuff. But as for this specific, really ancient. With this one, I got the least kernel panics and crap. And then next, I did increase this one. That there. Next, and we keep the default networking. And we say finish. So that's pretty much the same way. And then if we go to the virtual machine list, and then we have a new virtual machine here. And then you go to console, just like you did with the other one. But we won't start it yet because there's still customizations to be done to get this to work. So let's see, we go to hardware, and this is where I'm going to demonstrate, then you get a bit of a feeling of okay, how do you actually configure stuff here. So let's see, hard disk SATA. So that's already set up actually, because that was what I actually forgot to do. Actually remove that from my instruction here. Somehow I screwed up that I didn't change it in the original when I made this. I didn't actually do that in the wizard. I did it afterwards, so we take that away. So, but there are a few things that one could add to make the experience better. So one can add an audio device so that we can get some sound out of it. And which one was the one I was going to use? To really use that one, because that's the most compatible. Let's see. Okay. Yeah, and that'll be based on the Spice console, so you need to use the Spice console. So this is, I'll show the external application you use to enable it. So you won't have it on this no VNC display, you won't have sound. You'll only have that with Spice. And then we need to configure. And then it was the display also, since we're going to use Spice, then we need to swap this one too. As you see, we have all kinds of different Spice configurations. So we take the standard Spice, and usually I increase that to double. Not that it matters for this user. And then we need to check the boot order, but I think this is actually redundant. Oh, but it's already correct. You see here, it doesn't involve SCSI at all, which is good. So we get set on all AIDA, which is the CD-ROM drive, and then the network. And actually, I just find it annoying having the let's see here, networking. So I'll take that away. There's really no point in trying a network boot if you haven't got any network boot infrastructure. So that was the only change on the boot order, is basically to get rid of the network. So that's pretty much it. And then, let's see. Yep, there we go. So if you run it with no VNC, then you won't get the sound. So that's pretty much the only. So now it will start up the Montana setup. So as you see, it's a theme Linux. So anyway, it is a Linux distribution. It will ask you for the username, password, name of computer. So really, it's nothing that super exciting. It crashed. The installation crashed. It's supposed to actually come up with the extra displays and stuff. I should have the same configuration I had in the machine that I already installed. But as I said, this is what you get when you're dealing with old Linux distros. That there can be something very strange that goes wrong. So, yeah, I forgot that because I wanted to get audio to work. So if we to explain this in the best possible way. So if we go to hardware, and then you want to add an audio device, and as you see, the backend driver is a dummy driver, and because the only device that supports display device that supports audio, basically the bypassing the audio through, is the Spice device. So what happened is that when I did my first installation, I actually didn't have the audio device at all, and that meant that the display device was set to default, and then it doesn't seem to crash. The Montana setup process does not then crash. So as you see now, it's continuing on to the next like usual with Linux distribution. It's just like, you know, what's the language, other settings, blah blah blah, boring stuff. And then so that I did the installation, I completed the installation, and then I switched, and then I said, when I did it, then it was like, okay, but I could actually add audio. And then I went and I added the audio device, and then of course I noticed okay, yes, this needed Spice, and then I switched the display to Spice, and then the actual Montana OS, once it's installed, it seems to work, or it actually works fine, which I will show now with the Spice interface. So that was the trick. But then when I made my installation instructions, then I didn't remember that, and I thought, that what's the difference of if I do it? You know, I just cleaned up the order a bit in my brain, and but then it obviously the now the Montana OS installation program. I know it's the X Windows somehow crashes when we have I had the configuration. I had the audio device with the back-end driver Spice, and then I think it's primarily the display. So when I had display in mode Spice, then it didn't. Something in the X Windows processing emulation failed, and then it couldn't continue. But what I will do now is I'm going to shut down this, and then we'll have a look at the actual installed version with the Spice interface. So anyway, here's the theme HANA Linux with in the Spice display. But then I was going to try and get it to peep some audio, and it does that when you start it up, but that I couldn't capture. But then I suddenly realized I'm going to be copyright slammed if I try and play anything that's viable. But anyway, it seemed to be that the actual Amarok 2 player that's built in, even though it has some streaming capabilities, it seems to be all the channels seem to be dead. But anyway, this was the idea with this demonstration was to actually show that you can actually make a configuration for esoteric operating systems or platforms, and as I said, the issue I had with this one is that when I did the original installation, then I wasn't using Spice. I used the default display configuration, and then I didn't have the audio, and then I installed it, and then I said, well, that would be cool to have audio. So then I added the audio, and then I switched the display to Spice, and things continued working. And then when I just updated the installation procedure for the video, I said, okay, why do it afterwards? I can do it right up in front, so that, and that's what I did, and the installation stopped working. But that was the key to get the installation to work. So when I switched from the audio, I kept the audio device, and I switched it to the dummy device in the background, and then I switched the display back to default, not Spice default, and then I was able to go through the installation procedure. But that's what happens when you play with older stuff. But it is an example of how you can get older, even esoteric sort of stuff working in the virtual. It's much easier if you're going to install a maybe disheartening example for those that only want to use modern Linux distributions and Windows. But it's much easier to get Windows and Linux to work, because basically you can use mostly you can use the defaults. You don't have to mess around so much. But thought it was useful anyway to show that you can actually set it up to run odd stuff. So anyway, moving on. Just I thought I'd summarize here, but if you go to server view, and then we select the data center here, and then we take summary, and as you see now you get a summary of everything running on the data center. It doesn't matter how many Proxmox servers you have, it will give you this mind status here, so it'll show you is everything okay and how many virtual machines and how many containers are running. And then you can go down to a lower level, and then you can say okay, and then you can go to the summary, and then you can say okay, what's going on this individual server, and you get a lot of stats, you know, the main stats, CPU usage and loads and disk use, RAM and disk usage, and then you have it also historical graphs for pretty much all the different resources and what's been happening. And then down at the bottom you get these memory pressure and I/O pressure, so you can actually figure out is your server being under undue pressure, like when it's trying to share resources, if they're getting to be bottlenecks. And then you can also then go down to the individual container level, and you have the same summary beautifully. In this case for the container we were playing around with. And then you can also go down to the virtual machine and also get the same statistics, so you can have an understanding. So then you can actually drill down into the different levels and find out if it's getting under if the server or the data center is getting under too much pressure. Then you can drill down and find out which container or virtual machine is actually potentially causing issues. And if you go to the folder view, then you can actually get an overview of all the LX in the whole data center. What are all the containers that are installed, and then all the nodes involved, all the virtual machines that are configured in the whole data center, independent of what Proxmox server they're running on. And then you have the also, I didn't cover this in the video, but this is software-defined networking. So if you want to make virtualized network topology, then you can do it here. And then you get the overview of the storage situation, a quick overview of the whole data set. So I hope you found that useful. So it gives pretty much a good overview of the whole Proxmox setup. Maybe the Montana example wasn't the best one, but on the other hand, you saw how you can actually tweak settings if you need to get esoteric software running or operating systems running on the system. That might actually help you understand how to do that. If you're using normal Windows or Linux distros, then it's pretty much just you don't need to do that much extra configuration other than the disk and memory and stuff. But anyway, hope you found this useful, and I hope you still see the usefulness of Proxmox, and see you in the next one.